Hello Berlin, hello Internet, and welcome to the number 16 TouchDesigner Roundtable here in Berlin. I welcome you in the name of the Node Institute. Stefan, who normally is here, is not here today. He is in Erfurt right now and doing a dome projection. Actually, it's a dome, not like dome, but dome. Okay, it's a silly wordplay. Super happy to announce our three speakers tonight. The first person is Thomas Mann, over there. And he and his friends, over 10 years ago, created the studio FRAMEFIELD. They are doing VR, AR, and in general 3D, and medical, as I saw. Projects. And he's going to show the open source tool TOOLL, so TOOLL, and it's number 3, and it's quite impressive. So, TouchDesigner, be wary. The next person going to speak after that is, I'm sorry if I'm butchering this name, but I'm going to just say Ploypapus Phosri. Okay, there you heard it. And she is a multimedia artist and she's living here in Berlin, and her work takes on multiple forms, such as motion graphics, design, 2D and 3D animation, generative design and audiovisual art. So, it's the police. And she will show us how she works in TouchDesigner. Sorry, I have to cheat a little bit. She will show us her use of TouchDesigner in the production Chasing Waterfalls, a multimedia opera, which is partially composed and written by artificial intelligence. And last but not least, this time in person, I think everyone knows him already on the screen, but Markus Heckmann, Technical Director of Derivative, will show and tell the newest hot shit straight from Toronto. So I think that's quite interesting. Afterwards, we will have socializing as usual. On the other side of the street is the Omega Bar, and we reserved a table there for every one of us. In general, every speaker will have around 30 minutes, and afterwards you can ask questions, but you're also openly invited to communicate directly outside the door here or then in the Omega Bar. And then we will have between every speaker a 15-minute break where you can get refreshments on the bar, smoke a cigarette outside. And without further ado, Thomas, the stage is yours.
Okay, thanks for having me. I'm a little bit nervous, I have to say. Let's see how this goes. I'm very bad at preparing talks, so I think it would be very nice if it would be a little bit of interactive. So like if you frown, then I will explain more. If you say yes, then I will say more. And if it crashes, I will restart. Maybe like a couple of things, like where this thing comes from or what it is. So there is there used to be a subculture called the demo scene, which does like real-time graphics for fun in their spare time. I always used to say this is the best hobby you can ever have, because you have like great musicians, you have great designers and great developers coming together and doing stuff, and then everybody said, oh, like my effects look awesome with these nice little cool music clips. So it's like a little bit like MTV in real time. And it used to be very powerful and impressive in the 90s and early 2000s. Now it's like more, like the really good people went on, like for instance, IQ, Inigo Kielis, like he originated from the demo scene, for instance, like, and Mr. Dupe, 3GS originated from the demo scene. Like Cables originated, is still in the demo scene, I would say. And so was me and my friends. So we had a group, or we still have a group called Still, and we built our own software to do like these projects. And eventually we decided it would be fun to have like this as an open source project to do visuals. And for me, it was like moving a little bit away from non-linear editing of like video clips to more to VJing and interactive real-time content and connecting sensors and things like that, because this is more fun. So we built this. It's called TOOLL. If you ask me where this name is coming from, I can tell you later after a couple of beers. So far, we know it's a terrible name and it's horrible to search for, and but we are bad with marketing and we have other things to do than finding new names, and every attempt to find a new name was futile. So TOOLL it is. And it's node based, so it has a lot of similarities to TouchDesigner. So you know, the data flows from left to right or something like this, so you patch. You have like different layouts here, so you can use a little bit like a docking system that hopefully will improve. It's written in C#. It uses DirectX, so it's only Windows only. And it's completely open source, so you can download the source code from GitHub and compile it on the fly. If you run it from an IDE, you have like live coding with hot code reload, so you can actually code while you do stuff in C#. And of course, you can do the same thing with HLSL. So if you start it, this is what it looks like. And we have like a little bit of annotations to welcome new users. So for instance, you can double click here, you can zoom in here, and then it will tell you, hey, this is an operator. It loads stuff. And hey, you can take this and drag this into an effect and have the effect here. And if you have an effect, then most of the time you also have presets, and then you can hover over these presets, or you can hold the Alt key to blend these presets. And yeah, you have, you know, like the usual stuff, parameter windows and animations and keyframe stuff and all these kinds of things you need. Then this example is the starter example, and it shows a little bit how it's working. So we try to be very visual, maybe a little bit inspired by TouchDesigner. So we this is an LFO. It goes through time. Everything in TOOLL is based on bars, so it's closer to Ableton Live than maybe to something like Cinema or so. And the idea is that, okay, if you animate something, then you can reuse the same animation with a new soundtrack and just reuse everything, because you can just adjust the BPM rate and then everything will stay in sync. And of course, you can do this live. You know, you can tap on live and everything will stay in sync, and it will nicely blend from one BPM rate to another. Then we take this value here, we sample it, put it into gradient, then we take this gradient, we draw like a mesh here, we see this connected, and then we draw this, we have this set a camera moving around this torus, and then we put this into like this this effect here, and then you can, and of course you can, I cloned myself. And then of course you can always like go into like these preset stuff here and have a lot of fun like exploring what this thing does. And since it's all procedural, so you can go back and have like, okay, like how would like this final result be affected if I go earlier and earlier and earlier into my procedural graph to check out, for instance, like here we have like a bunch of like tori that, yeah, I don't know, like maybe, yeah, I don't know, not the most beautiful example, but it shows a little bit. To help me a little bit with my talk, so we have, and to help a little bit the new users coming to TOOLL, we have these playgrounds here. So we can jump in here and maybe unstick that. And it's like, it has a lot of how to animate stuff. So it tells me, okay, you can take the time and connect it to a layer rotation. Here and we see like that we have, I don't know, like 68,000 seconds. so right now, maybe I should tell this. So one of the things that was annoying for me in the previous iterations of Tool was that you have to have play to actually work on motion stuff. And most of the time I was actually doing procedural animations and procedural shaders, and then it was like awkward pressing play all the time, and then you had the soundtrack, and the soundtrack was moving, and then the soundtrack was ending eventually, and then you had to rewind. And here the idea is that we have something called like idle motion, which means that right now the time is running because like this little tick here is running. And if I stop this, it will stop at any time. No, I can play here, and if there would be audio, okay, we don't need, but there could be audio there. Then I could stop at any time, but if I activate this idle motion, it will like keep on from there. But if I scrub the time to this place, it will always be like this precise time of the, you could start, okay, how would my scene look if I add like, let's say, if I started adding this here and add maybe like and then maybe like add a sign or something. So how would this affect my procedure animation? And you can actually play with that. And maybe I should also like attach this here. So and then I don't know. Probably it would look very awkward because the period is too low. I don't know. Then of course we can combine stuff. Let's say, my heart is in interaction design, so I'm probably better in interaction design than in, or like, I have more fun with interaction design, and this is my day job is interaction design. So I once in a while go into tangents and like think about like how should a graph look like. How should like, you know, like if you like, how should like a timeline, I'm like, you know, this is my porn, like going into like how should the timeline work, and how should like how should a timeline work if it's like not easily subdividable, and then they go into hey look at After Effects, they can't do it right. Yeah, of course you can add stuff. You can do yeah, this might be a good example. So we had like these guys here. So I love to work with like my let's say, okay, maybe like a complete tangent here. So like if you measure a tool, like how good is a tool? So like how good is like something like a creative thing of expression? Like how good is it? And of course, in the demo scene, like everybody builds its own tool, and we go like, my tool is longer than your tool, and like one measurement for me was always, okay, like how quickly can you actually build content? You know, how quickly you get an idea, how quickly can you actually express yourself? And for me, like the ultimate thing was actually VJing, because like if you hear a soundtrack and you do stuff from scratch, and your tool is so expressive and so fast that you can actually, okay, like this sounds like Wayne, and then I do Wayne, and then I mix it into that. This is the ultimate tool for me. So like it should be like as expressive as it can actually be. And so this is the level I want to achieve. So and for like like I said, okay, I have this building block. Like I have this LFO, what can an LFO do? And then like, okay, like I want to be able to like express like how fast is it? Or like what's, you know, like what's the level of like the bias there? I want to go in here, like what's the weight? And then the weight is always, we had like we are on bars, which means like if I go by this guy here, it's you know, like it's always to the beat. It's going to the beat. And so with these kind of things, you can, and of course you can always like go in here and say like, I'm like on the, sozusagen, I'm let's say, I have this amplitude here, you can drag this out and then drag this into MIDI controller to patch this on the fly, and then you can move this into presets and blend these presets. And eventually like this, at least for me, like this brings me to the flow of actually like, okay, I'm in the moment right now, I'm listening to the music, and I I transfer them into visuals. And this is like a little bit hard to describe, but this is maybe where I want to go. So then let's move on. We have like these guys here. So like tons of procedural animations. So we love this kind of stuff. And yeah, tons of like, yeah, and eventually if you connect all these together, so, oh, this looks wonderful, not, you can build like simple stuff like this that should be readable if you know, you just look at it and you don't have to get an like instruction set of what this does. You just look at it and it's evident what it does, because like all the nodes are evident and they are like so small and they do so little things that and like if we let's put this in, like in a full screen mode, so like then you could actually go into like, okay, like we have a counter here and then we sample like this, and this samples a graph, and this goes into like the render clearback color, and we take a random string and then we combine this into, and then I have to say I stole this one from TouchDesigner. So like the thing with, you know, like having like the text editor directly in there. I was always fascinated with this. I always wanted to do this, so I did it. Yeah, and eventually, you know, you do stuff. So let's clear this and let's go out. How am I doing on time?
You're fine.
Okay, I'm actually fine. Am I speaking too fast, too confusing, too? Okay. So we went into this, and we have half the time left. So there are like, yeah, maybe quickly go into this. So like this is an example how to draw stuff, and we have the same thing again. So we have maybe I should mention like the colors. So I'm a big fan of like colors in a reduced way. And one thing I stole from another tool that is called Werkzeug with 2K, just a VS with 2L, that they have like operators, and I said like, okay, operators have a primary output. In an ideal case, they have like one thing they do, and the type of this primary output defines the color of the operator. So, and this is, we do the same thing. So we have like this brownish stuff that outputs GPU information, like stuff on the GPU. Like this stuff, basically, you could say it's a little bit like the execution path in like the white line in an Unreal blueprints. So it's commands like switches and loops and this kind of things. The pinkish stuff is textures, and yeah, there you go. So like it really helps a little bit to see like, okay, get an overview of like where am I looking at, where am I here, and so then looking at this is like, okay, like there's obviously like some kind of geometry, and this geometry is like something we do with this geometry. So we draw it and we set this camera, then we render this into like texture, and then we do some post effect application here. And then always like if you click this, I'm not getting enough of like doing this because I think it's this worked nicely. You can use like these views here, so you can also go in there, you can change the resolution, see like, okay, how would this look in 4K, or how would this look in 8K. So I don't know why we do it, but you could do it. So let's go back. Oh no, my computer is getting warm. No, let's switch back to. Then I think this was not so valuable. We can look at this quickly, and let's see how my computer is doing. Yeah. Yeah. If anybody knows like a little bit about DirectX and syncing, I have this problem that if I have an HDMI with an external splitter, my frame rate halves, and I don't know why. So if anybody ever figures out like why this DirectX does that. But anyways, so we this might be an example of something more complex. So we once again have like, we load a geometry, we displace the geometry with some effects, we split the vertices, we draw the mesh, we set the material, then we generate like a texture on the fly. So of course we could load something, but we can also like build like very complex graphs to build like textures. We apply this to like the emissive color in this case. We set a we set a point light. We have some lens flare there, and then we draw this. We add some SSHO and some glow and some color grade, and this is roughly how like a more advanced like scene would be set up. Then we have this playground here. Shows a little bit of, so we click this here. So we see, we take the same image and we apply like a bunch of like these effects. We see how this is like switching through the different effects here. We try a lot to make things understandable. So for instance, like we see that this line, so if you pause this idle motion here, we see that this line is being fed because it's being currently evaluated. This one is not evaluated. So like I think with TouchDesigner is a thing with cooking, so we don't have this. So if things are connected and evaluated, they are evaluated. And if things are not like not connected, they are just not present in the graph. So they are completely ignored. And so you will always have like this thing, if something goes wrong, you can always, it's always predictable and the execution order is always clear. So we have like this pick texture here, and we pick one of these textures. This might be the most ugly example of all of them. So maybe we move forward. Like, let me take this guy here. So I mentioned earlier that we have live coding, a little bit like shader toy. I think it's of course much better than shader toy. So you can double click on a node and it will warn me, hey, like, you know, like you are entering like a library op. So the tag ashes here, it is in the namespace lib image generate, and by default, like this lib is basically something like the common operator set that you are not supposed to enter unless you know what you're doing or you're making a pull request. I know what I'm doing, so I double click here, and then we can go down the rabbit hole. So we have a setup operator here. We can click in here, and now I'm in close to DirectX API level. So like this is actually the really like how on DirectX you draw stuff. You know, you have like you have like an execution here. You have an input assembler stage, a vertex shader stage, a rasterizer stage, a pixel shader stage, an output measure stage, and you draw like a triangle. And this seems to be verbose, but if you are into this kind of stuff, it's ridiculously powerful because you can actually look into the DirectX API how they want this, like what are the modes that are supported by the API, and you can use tools like RenderDoc to actually profile the stuff, and it will basically match like this setup. So it's super nice and powerful to evaluate why certain things are not working. And so in this case, we don't have to look at this. So for normal users, this is completely, you know, you don't go in there. But the nice thing is that like we reuse this. The only inputs we are exposing is like the source code here and a bunch of parameters. These are like multi-input fields. If you click edit here, then I hope my Visual Studio is going to open. And then of course we have like a powerful text editor, and you can go in here and do later live shader coding, like float for. Thank you for this tooltip. Okay. I hate this keyboard. So of course, like Visual Studio like has wonderful extensions for like HLSL code highlighting, and you know, like if I write something stupid, it will tell me in advance before actually pressing space. Like if variables are like not there, it will tell me. So like it's a lot of fun like working with these things, and then we can quickly jump through. Like we have a bunch of examples here, post-processing stuff. Maybe we enable like this idle motion here, so like directional blurs and the usual display stuff. And I thought like sometimes we go into interesting realms, like I love this guy here. Yeah, all our example images are frogs. I don't know where this comes from, but frogs. So like this guy, once again, you go in. No, actually, no, this is not like, it takes like 2 textures. It loads from the drive, and then it takes like a third texture that is generated procedurally, and this is going to use to mix these 2 things. And this is of course like super powerful because you can nest this stuff. You can go in here and add like more variations, and then go in how like this would affect the blend mode. And once again, you can and of course maybe I should show this once. So like the roots of this, all of this is in, I don't know why it's called nonlinear, but I think it's called nonlinear editing. So you have like you can add like a soundtrack here, and then you can set keyframes. So and you can do the same thing here. So you can actually like go in here and say like I want to like add a bunch of keyframes, and then look how this is being how this looks in the animation. So and yeah, it has the keyframe editor is actually, I think, is pretty good. Then I think we talked about this. So this actually the might be the most impressive thing, or like this the thing I love to show off. So if it would work, there we go. So when we started looking at other content creation tools, so one of the tools I'm obsessed with is TouchDesigner, of course, but Houdini. And I have to say, I'm not a user of both of them. So I'm not a TouchDesigner user, I'm not a Houdini user, but I read manuals and I watch YouTube videos, and basically I think I spent like many hours analyzing how Houdini does stuff and how this could be transferred into something that is flexible enough for real-time graphics, but expressive enough to do like very complicated things. And like what I ended up with is like an API which we call points. And a point is basically like it's a reference in space. So it only has like a position, quaternion for rotation, and a W attribute. And the nice thing is that it's like 8 floats, which nicely packs into GPU memory. So it's really cache efficient to have like many of these. And so you can create them on the CPU, of course. So you could connect them to, I don't know, like MIDI controllers or OC sensors or whatever. You can upload them to GPU land. And then you can do things like, so maybe like if we pause this guy here and like bring it into like, so like this is the reference point here, and then we take the reference point and we take this radial points and we repeat radial points at this one point. And then we use another radial points guy here. So like these things here are basically radial points repeated at the radial points, and then we take the original and then we draw meshes there. And the nice thing is that so it sounds somewhat, why would you ever do this? But it's amazingly powerful once you get the hang of it. So because you can do things like, okay, let's say, okay, to start with, it's on a GPU, which means millions of points. So right now we have 100, but you know, if I add a couple of zeros there, it's still like running. So we can offset like this, like, you know, okay, like this is probably way too much. Here, maybe like we edge this like this. Maybe we take a couple of cycles. So now we have like the same thing here. So we have like, I don't know like how many cubes this are, but a lot. And so maybe reduce this a little bit to save the fill rate here. And then you can go in here and just say, okay, like how would this look if I add, for instance, if I apply a noise here? And so maybe I reduce the frequency and increase the, like this guy here. And then I could go in and say, okay, how would this look if I animate this? And how would it look like if I take this guy and randomize the, oh no, this was a bad thing. Oh, this was even a worse thing. Randomized points I wanted, not random walk. So it's, we can, so maybe we should also like use the, so we can, for instance, like randomize this W parameter, and the W parameter is also being used for like scaling the cubes, and you could use this for all kinds of things. So you can also do this for, and for instance, like changing the color or the direction, or like the apply, like for instance, you could say like, okay, like the noise should only be applied when the W parameter is very high, things like that. And it's, I think I'm making a very bad, yeah, I'm not very good at explaining it right now. I'm a little bit nervous, but it's very powerful. You can trust me with that. So, and then it's compute shaders. So once again, you can go in here, and for instance, if you look at this randomized points thing, look at the compute shader. Like the compute shader is messy code because there's commented code in here. But if you look at this, it's like this is ridiculously like, you know, like this is like 20 lines of code that does this effect. And of course, you can go in there and write new code. You can also like let's say like, this is an interesting effect. So you can go in here, simple definition, duplicate this new type, randomize point to user picks to examples maybe. Test.
If I could chime in to keep up with the timetable.
Excellent.
We are at the 30-minute mark, so you have 15 minutes, and either you can ask questions or maybe you can explain something more. I suppose questions is a good...
questions is good. Question helps me.
Would be nice if you could retell the question when it's asked, so the audience on the internet also can hear it correctly.
Sure.
So.
Can you show how the keyframes would work on timeline?
Sure. So you can keyframe everything besides strings. I'm working on this. Animating strings would be really nice, but you can go in here and say, like, for instance, like we have this, like we had this randomized points, for instance. You could say, okay, add a keyframe there, add a keyframe, like make it big, and then most of the time I'm working in this mode here, and then you can go in here and like move stuff. You know, it has like scaling and retiming and duplicating. So it is basically a full-fledged keyframe editor. You can do things like smoothing. So you can also do things like after curve cycle or cycle with offset a little bit, like you know. So yeah. You can also do things like it has proper snapping. You could say like, okay, I need a sequence that does precisely that. You can actually go in here and say like, okay, I want to snap this to precisely 16 bars, and now it's precisely 16 bars. So, yeah. And of course, you can do this with all kinds of like things. So, yeah.
And can you change the shape of the curves or
Mm-hmm. I mean, like with like tangents and stuff. Yeah, you can go in here and then so like I don't know, like if this is what you meant, but
yes.
Yeah, can do this.
I really like your value ladder.
Here like thank you, neighbor. It's not there yet. We are constantly improving and it's not intuitive, but I'm not going into that. It's perfect.
Is your timeline, is there only one global time, or are there local time instances as well?
It's so like the idea is a little bit, you have operators, and the operators are projects. And so maybe if I go into, let's say, I'm kind of scared to open. Yeah, because like the frame rate is. Let's see. Actually, it's doing nicely. So so this is a. Let's see. If you move back to this. So this is how like a proper project would look like. You know, like you have time clips, and these time clips they go into like these are paths, and then you have like nested scenes that go inside and that do stuff. So if you turn off the gizmos here, so it's actually yeah, it's a dark animation with like doesn't make much sense without the audio soundtrack, but inside this project you have like you attach normally like these soundtracks, and the soundtracks they come with a certain BPM weight, and this is basically the timeline you have. You can also like, for instance, like this guy here, it is like a sub patch. You can double click in here, and then you have like a local timeline, and every time you select keyframes you basically get the keys. So yeah. Sorry, I forgot. The question was, how does timelines work? Yeah, well.
Is it possible to record like an automation curve?
I think this is the one. We have a very active Discord server, and so like the let's say we have a blob here. It's like the you can I don't know, like take like this, and then you can actually no, this was that example, the move animation, like this here, and then float vector 2, and then MIDI. So you can actually do this. You know, like I don't know, like if I here, so you can't. I don't know, like yeah, you actually you can. I don't know like how this one user does it, but he does it all the time. The problem is that it records like one frame per one keyframe per frame, and it does this for thousands of frames. Eventually, it will say like, well, you know, are you? Yeah, and then it gets slow, and so and there's no curve optimization yet, but it could be. So yeah.
More like a general question. What is your sort of what's the focus on the use case of this? Is more like for because it looks like you're really making this for like music videos. It's all about audio, or is this also for like installations and real time things?
So the question was, what is the target audience maybe, or the target use case? And so I would say it's a multi-purpose toolkit, but then I would steal it from VVVB, which and it's so if I would decide build something that does one thing really really well, and if I would have to pick this one thing, then I would say it's VJing, because I think VJing I think like it got stuck there. You know, like it got stuck like 10 years ago, and if you look at visuals, like just the name is already horrible. You know, like why would you play like pre-recorded videos? Like this is, you know, like, and so like the thing has moved on so far. You know, like with machine learning and all this, you know, you can capture stuff on the fly. You have like, you know, you could actually, you know, read like the smartphones of your audience to see like how they're dancing, like all these kinds of things. And TouchDesigner moved it forward a little bit, but not enough. And so this is like, if I would have like one target audience, this would this. If on the side way, you can actually do like musical or like museum applications with that, would be fine too for me. So we built like a small like installation, but you know, like I mean, at work, at FRAMEFIELD, we are using Unity. Like, and like there is just no way you can beat Unity when it comes to asset importing or like UI building, like stuff like that. Or like, you know, like if you want to do stuff on the web, you use cables. Or like if you want to combine it with like user interface. So this is definitely all the things that it's not good at. So, but live visual stuff, it is good at. Yes.
What about mapping and multiple video outputs?
So like regarding mapping,
Or just more than one video output?
so like the interesting thing is that for some reason, like Deadmau5, like who is like a very active TouchDesigner user, like he like tried it out and he was like really into, oh, like I really like that. And then the first thing he said, like, I want to have like this, like this we built. The final thing he said, like, I want to have like reprojection, you know, I want to have like, and I'm looking into that, but it's tricky. So like what you can do is actually you can open, it's like for VJing stuff, so you can open like this a second render view and you can map it there and have like this resolution. And this works really nicely for VJing, so this is what I'm doing all the time. So like one external screen works really nicely. And of course it's open source, so like you could actually set it up to have like, I want like 5 external screens, but you would have to write C# code for that. So there is no, right now there is no user interface to do these kinds of things. There might be eventually. I personally, I only add stuff that I know what I'm doing and I'm using. So that's why if somebody from the open source community goes ahead and does like, okay, I want this interface and I need it, then yeah, it would be a good match.
I have one more question. What does the fresh default patch look like when you open the software?
When you open it for the first time, it looks like this. So like there is this home canvas. Right now we have like a lot of passionate discussion on Discord, like how this an empty operator should look like. Right now, like the only thing to create a new operator is you take like these guys and you say symbol definition, combine the new symbol, my patch, and then combine, and then we'll create a new patch, and you can go in here and start working. And I see how like this is like not really intuitive. So eventually we will have like a file, open new project, and it will, you can pick like, okay, should it have like texture output or command output? Yeah, and like some of the stuff, is ridiculously simple to do. Like this would be, I don't know, probably like 2 hours of work or so. Some of the stuff is super complicated, like having this multiple output with resource management would be very difficult. It's, having, for instance, like it would be really nice to have shadows. It's ridiculously difficult because then you need multiple render passes and you need to tell like all these shaders which like should I use like the full fragment shader or should I just use like the depth, you know, like some stuff is complicated. From the simple stuff, we are getting there. So we now have like this GitHub page with issues, and we have like this little project where we try to prioritize like these issues and feature requests. And like for the simple stuff, it will move fast, quick. So I assume a lot of stuff will come. Some stuff honestly, I don't, for instance, like I would really love to have like character animation and skinning. We have a little bit of GATF import, but yeah, I'm not a character designer, so I don't really dare to start that because I probably would do something that would not work as people would love to use it. So.
I have a question. You said the main use case would be VJing.
Mm-hmm.
So does it take live audio, and is there beat detection? Because you also said it's around beats.
It's good. No, it's so like let's say the demo scene people are obsessed with audio. There are some really smart people in the demo scene that are like, you know, they are also like the guy who also developed part of that. He worked, I don't know, for a couple of years at Native.
Yeah.
So they're saying, no, it's not good. The latency is way too high. I would say it's completely sufficient. But yeah, so like you could, you know, there's like this beat detection, and you can go in here and say like, what's the audio input, and then you can have something like Wasabi, and I don't know, like, okay, like it's working a little bit. I don't know why it's not. So like, there's a like beat detection there. It's okay. So
That's nice.
I'm still having a hard time to, like this. Like if somebody can tell me how to distinguish a hi-hat from a snare, then I would be very happy. But yeah, it's not too bad. For basses it works okay.
Yeah, thank you. I think this would be a good point for the last question. So big applause for Thomas, please.
Hi everyone, welcome to my first presentation ever and first project in TouchDesigner. One of my biggest, actually, first live show, first time working with TouchDesigner. So it's quite big. Today I'm going to talk about my TouchDesigner, how I use TouchDesigner with the project that I've been working with is called Chasing Waterfall. It's the AI opera that I just got the premiere in the 3rd of September, and we have 3 days as a show in Semperoper, Dresden. So thank you again, North Institute, for having me here, which is like quite special because 2 years ago I was like, I learned as a beginner, very basic of learn TouchDesigner, and then I have to do 2-time workshop, beginner workshop course, and then Stefan not here, and he was like, second time I also did the beginner because I didn't understand TouchDesigner at all. And he said, like, Ploy, you made a mistake. You made the second workshop of the beginner. It's like, no, it was not the mistake. I meant to do that because I didn't understand TouchDesigner at all. And bam, here I am. So welcome to my presentation. So a little bit about myself. I'm a multimedia artist. I'm usually, as a freelancer, I'm a motion designer. Working, came from the background of 2D, 3D animation, and I would call myself, I'm generalist as a motion designer. I'm doing quite variety before I start TouchDesigner. I'm working 2D, 3D animation, motion graphic, and compositing, editing, you name it, as a post-production person. And of course, like focus mainly on visual, like making a beautiful visual. That's my focus point. And I would call myself like I'm a self-taught artist, and I always like to explore the visual, how to make a beautiful images, experiment with different software. I start with After Effects, Cinema 4D, and now 2 years ago I learned TouchDesigner, two year and a half. And I can show you my website. I have been working, before I start TouchDesigner, I've been experimenting a lot in Cinema 4D, and this is like, I spent the whole two years roughly make an experiment with the Cinema 4D. It was my passion in the past, creating beautiful visual and learning Cinema 4D at that time, and creating a lot of random art. And you can see my background totally different from what I'm doing right now. And then I have a couple of projects as a motion designer with agency, studio design, and at some point later I was like, I think I have enough of this kind of thing. I've been working for almost 10 years and I need to change to something different. And then many people know me from Instagram since 2019. I was experiment a lot of TouchDesigner, exploring especially interactive and generative art. It's very difficult, but I really like to know, but it takes me a very long time just to get used to it. So I decided to do, okay, let's do everyday visual exploring, and I create like, I think it's already 360 something visual that I've been creating for such a long time. And since then I start to get the client working with TouchDesigner. One of the beginning big project I worked with I think this one called from Our Silent Canvas, and this one I make music video for them. And one of the big project that I fully use TouchDesigner basically You can check my website later. It's my website ploy.de. This music video is a long pieces of different visual using TouchDesigner with audio reactive, and I quite like the results. You can check it out later. And then after that, I also have a nice collaboration with continuous having project working with TouchDesigner. This one I was collaborate with Emika, that she also generate her music, like generative music, and I find very interesting that we have the same approach of, I just start learning generative art and she did her generative music, and we collaborate together, and I really like the results, so I would like to just share with you. But I think I just go quick because I have a lot more to talk about the chasing waterfall, so you can check out later in my website. So we can start with our chasing waterfall. So first I like to show you the trailer of what this general of this opera look like. So I was collaborate with the company called Phase 7 Performing Arts Berlin, which they co-create co-production with Semperoper Dresden and New Vision Art Performance Arts in Hong Kong, and quite big production. So I can talk about a little bit what kind of story that we're talking about here, like what story of Chasing Waterfall is like. Basically, with this story talking about how we generate our, like, you live in this digital age, right? You're going to Instagram, basically you have your profile in LinkedIn, and you create your basically ego, or I would call it persona. Your Instagram is your another persona, your LinkedIn is your persona, your ego, and our everyday internet is basically you keep create your persona, your ego in different place when you're using internet, and everything you deal with is start to be part of your life, and AI will potentially at the end, which is where in the AI age right now, that maybe the AI will like get you data, you know, like they know what you like, your clothes, your personal style of clothes, of color, your food, everyday life, and they collecting your data, and maybe they even know you more than you know yourself. And this is what Chasing Waterfall is talking about, like our life in digital age. And you can see people, this is the main character, so the rest of the character, they represent of digital twins. Basically, one is the dope, one is the successful, one is the young version of yourself. So it's showing you different perspective of your personality in the internet, using internet. So what's so special about this AI in this production? Basically, the AI is co-creating as a composer. She, in this case, AI, she's also singing, and every performance, she's creating the text, and she also creating the text that she was singing and talking in the part of the show. Every performance, basically, there will be different text generated from the AI. So someday she will have not a nice mood. If you're looking, I didn't prepare here, but if you're looking at the Semperoper website, they show different dates that the AI is saying different things, how trauma and how AI worry about our society is pretty spooky, actually, to see that how AI concerned about their role with the human, and they being part of entertainment for human, which is like so very special to me. And this already strong concept that I was really be interested to be part of, and very excited to be, even though it's really crazy project, but it's too good not to deny to not working this project. So what's my task and my role in this project here? Basically, I got invited to create 2 video art for 2 scenes. One is called Overture. Basically, it's a neural network that will be the first first scene that the audience will see at the beginning. And the second one, and many of you already know that I'm talking a lot about, is a face scan that the audience can be participate in this story of the AI as well. So we will have a face scan, and then we'll put the face scan into the scene later. But first, I can start with the overture, how I shift to the part of the tour. So overture is about that the visual want to represent that we want to introduce the audience to understand that we are entering to the AI scenery, that the AI is sleeping and slowly waking up. So what I got asked, since it's the first scene, we want to have a slowly introducing what the director want was to have like very subtle, dark, and very reduced and dark. Just see how the AI is sleeping and start to wake up a little bit. And this visual will be projecting on Frontgasse, which is in German. In English will be gauze, like a mesh curtain that is in between the audience and on the stage. So you can see through this dark curtain, which is so that's why this visual require very high contrast. That's our idea to present and have to work into this concept. So my first stage of the design, how I approached at the very beginning. My beginning idea was I was thinking to do something like maybe abstract of the networking of the brain in the abstract way. So I have 2 types of visual here. Like one is very organic, like very abstract organic. One is very edgy abstract, but I want to keep like a certain shape of the pattern. It's abstract, but they have a strong certain shape of it. Well, but then didn't work out. The director didn't want it, and it's like, we wanted to make sure that the audience would understand what we see at the very beginning of the scene. So we go back to the style of the actual neural network, like a medical kind of look, so very realistic kind of look. So this is also the state that I start to be playing with. I can show you the other, how as a video, this is like, I think this is also audio reactive as well. And of course this one got reject, so I move on to something more concrete, the design with the actual realistic neuron object. So I have to pause because, as you can see, it's a halo light here.
Yours is much cooler.
I know. At the end I like what I did, but I also struggle a little bit at the beginning. It's like, how can I make it more interesting? And very beginning still didn't work because, as you can see, the halo light when you're projecting on the gauzes it needs to be strong contrast, and you wouldn't recognize with the so much light. So I need to develop some more into this, and so this is almost there, but it's not. So.
Sorry. Can you say a little bit about the process of how you created these? Did you
I will talk about later.
Sorry,
Yeah.
I'm just very interested.
I just want to show how I play around with the idea and how it developed. And it's getting a little bit more in the direction. Different camera movement, and basically this is the close to final, even stronger contrast. Basically, a lot reduced, a lot more contrast and darker, and this is the basically a right direction. So come to the final workflow. At the end, after playing around, so I basically I was familiar using before. I have to say that TouchDesigner is such a new thing for me. It's like I started two years ago, so I have to work my 3D part in Cinema 4D. Basically, I arrange my neural network into in Cinema 4D, also animating camera with the help of my boyfriend is helping for animating the camera to have a nice like go through one neuron and how I would present it, and then I import it in TouchDesigner in FBX file basically. In this case, I was struggling a little bit. How would I animate in TouchDesigner, because I would like to audio reactive and animate at the same time in TouchDesigner. And the way I approach it, basically I end up creating a custom made component. So I can control how because I wanted to present the way that one neuron will be slowly show, and the next neuron lighting up little by little, very slowly. So I create a component for that. And the way I animate, partly for the light, when you see the neuron is firing the light one to another, I use UV mapping and animate the texture. And yeah, I can show you the scene if you're interested. Like, yeah. I think at the end I end up working too much just to animate, because I create a lot of for me it's like a little bit complex system, a component just to animate. I hope it will. Okay.
Just a little note, it's 21:24, so you have 5 minutes with afterwards 15 minutes
Okay.
questions.
Because
Or
I
we
still
can squash the questions and
yeah, because I still have a face scan part that I didn't even start yet. But I will show quicker that I close project file again.
Is this show running live out of TouchDesigner?
This one is not live, but I wanted to audio react and be able to animate. Oh God, it takes very long.
I mean the actual performance on stage, is that live TouchDesigner playback? Or is it recorded and
These two scenes, this one is the pre-render. So the face scan is a live performance.
Maybe you
Doesn't
want
work.
to continue with the face.
Yeah, I think so. Yeah, it just don't know why. It's just really heavy because my neuron 3D is just enormous and pretty heavy. So sorry for that. How can I kill it? I'm just gonna kill my way like this. Yeah.
that never happens.
So, if you want to see it, this is the final look. I can just show quick. I hope internet work. Nope. So I will just gotta scroll quick because it's. So this is the final. Yep, internet. We can talk if you want to see the whole thing again. Let's move on. So let's move on to the face scan part. Basically, this scene is talking about the AI offering the virtual friends to the main character, because the AI think the main character must be lonely because she doesn't have like and follower enough in her social media. So the scene is talk about, here, look at all the friends. You can have many friends, and those friends, they are the audience that visit by the Semperoper. And we wanted to have this scene in the, I don't know if you know, watch Minority Report, like H2D HUD interface style, futuristic. That's the style we go for. And the workflow of the face scan, basically, we aim to have 20 to 40. That's TouchDesigner. For me, my system can deal with, basically. And more than that, I have to think twice. And how do we scan the face? We use iPhone with the it's not the LiDAR, it's a frontal camera, like I think it's called True Depth. By using the Scandi Pro, which is really one I found the most intuitive. Like you can just do a little bit and then you have pretty decent shape of the face, like in the very quick time. So we use this app called Scandi Pro, and our aim output is of course OBJ and PLY, which is point cloud. And then after this, I will have to apply 2 to 3 effects. Like we aim for 2-3 effect style of the face effect. And now I come to my design development. So I have a lot of time, like visual research into how face effect could look like, because the idea is the AI. We wanted to have the idea of you have a person of the clean face, and then the AI will manipulate your face into something else, because you want to show that how powerful AI can manipulate you and do something to you, can control you, and that's like a kind of idea. And I have tried different faces style. One with the wireframe with ASCII style with the number and stuff, and one that I've been focused is diffuse reaction, thanks to William, that I learned from William this technique, very useful for, I actually used this technique for one of my face effect. And the other one is the point cloud, yeah. So I hope I have time for my visual sketch. Do you have long time?
15 minutes,
15 minutes.
including questions.
Oh, okay, that's quite
There
short.
will be no questions.
Yeah, barely. Okay, we can go through quick. And this first one, it was been a strong, preferable style of the effect. So basically, polygonal style of effect, like reduce polygonal of the face. And then I've been developed into some more. You can take a look. And this is point cloud. And this is diffuse reaction. And of course, playing the idea of the HUD style, like how can I arrange, give a certain look of the HUD style interface.
Basically, a reaction diffusion, you're using it to control the textures, right?
Exactly. I with the normal, exactly on the foam material, and you can see it's super random. It's like, how do I do that? And thanks to Node Institute, I wanted, I have a support from the Node Institute for this project as well, as you might already know. Everything's all over the place, because it's like, how can I do that? And this is more or less like close to final looks.
You said this was running real time?
This got to be real time, yeah.
During the show?
Is the HUD TouchDesigner?
No, this is the I animate in After Effects, and then I made as a layer in the front. Called looking for different kind of looks. And then we come to the how I define the final workflow for this this scene. Yes, since it live is a live performance part, so I have to use many faces, and I have to find a compromisation, what kind of output that I should use for, I divide into 2 parts. first one I have to show like maybe 40, 50 faces at once, like flow of face, and also combined with social media, sticker, follow, like, and at the beginning I was using OBJ. It's super heavy. It's make my frame rate is just so slow. So it's like, okay, let's use PLY, so which is point cloud, much more lighter. So as you can see, this is the point cloud in the scene that you can have a certain face. It almost looks like a photo, but you can rotate in 3D. If I use OBJ, which I try a lot before, it just, if you want to have a lot of face, it's just very heavy to my scene. And then the second part of the faces scene, I divide into the three composition, basically three styles of presenting the face. So one is a carousel style, will be in the circle, and second one will be just single face that you can show fully effect, like fancy effects. And the last one is the slot machine. And those three compositions will combine with three different face effect. With the first one I call delete face, like you saw before, like reduce polygon on the face, and one I call terminator, basically diffuse reaction, and the last one is the wireframe with the ASCII style. So this is the carousel kind of look, and the focus face, and the last one is like slot machine. I was planned to open the project file, but I don't think I have time anyway. I can just go through quick. So this is style one with the polygonal face and terminator look, and of course with the ASCII with the wireframe. So this challenge except was my first live performance, and a lot of effects in there. The scene is got heavy, so what I had to deal here is a lot of things going on. Basically, I'm learning to sequencing and transition from basically the whole scene. I divide into small sub-scenes, so I need to learn to transition one to another, which is quite challenging. And the other one is like I have to make sure that the face data, the input that I have is correcting that can be deal with my system that I have, especially position, if it's at the center of the scene or not, or how big the scale of the face, or sometimes I got a weird rotation, the face just look down, and I don't think I would have time to rotate back again. So everything is counting here, and every node basically calculate properly. I keep checking my performance monitor all the time. Is that why it runs so low? I have to check back to performance monitor which part of the scene got heavy, and back and forth all the time. So every node was counting because I have three effects and I have to deal with those effects. And also I also have to have many time rehearsal, because in the performance I will have like roughly 40 minutes to start. I have a team to scan the face, and from scanning the face until I receive the file, I receive those faces, and then I will put in my scene. I have 40 minutes to do this every performance. So I have to brief with my team to, can you get that? Run down to my technical room, put in the scene, check everything is okay within 30 minutes, and it's quite challenging actually. And that was what's happening there. So I have a photo booth for face scan, so people can come and scan, and my team will run down to the technical room. It's like, here, let's get the file, and then we have to go back to scanning, and then they have to come back and forth. It was like not relaxed at all. I have to say. So at the end, I want to point out that I got help with Stefan, which is he's not here today. Maybe he listen right now. That thankful to Stefan, helped me for his Q engine, so I can run live performance within the time frame that I have for each shot. So, and at the end, I'm using MIDI controller to animate different part of the animation. Like for example, I could use MIDI to control from cleaning face, transition to the face with the effect with the MIDI controller, and transition to fade in, fade out. So it was quite useful. Do we have time for which short video?
5 minutes.
5 minutes, yes. So I can show very roughly how the final visual look like. So this is point cloud faces. At the end, we were worried that anybody will participate into scanning face. I end up have 150 faces in my system. It's like, okay, now it's too much. I can't deal with those. My system only ready for 40 face maximum, and that's how I can. But everybody want to be in the scene, of course. But yeah, I did my best.
Are you using like your rendering, or are you compositing all this, or how are you dealing with having so many point clouds at the same time?
Yeah, I didn't talk about it. Basically, if I have more time, of course, I create a lot of component for each face effect, and each face effect I make on top of the component to another component to see this component create this different effect phase, and a lot of same different phase effect on another system of component. So I have twice of component in my scene, and I end up creating like a factory of component at the end. So it's very complex system, because one shot you can have like 3 effects and different phases all the time. And of course, like the components start to be confusing for me at the end, because I have to be able to feed the face of the new faces of the audience in a quick time. So I make myself to understand my component, but it's still not enough, because we're dealing with 50 faces here in one show, basically, and that's pretty challenging.
Is this also projected on the gauze? Or how is this?
This one project on the gauze as well, yeah. So basically the curtain will come down, and then this scene is done, they will put the curtain up and into the stage. So that's about it. And I will say technical question, I would be hard for me to explain, but in the design process, I'm happy to answer. So, any questions?
You have a background in using, I think it was mainly Cinema 4D, you said?
Yeah, I always explore how to make a beautiful visual, but don't ask me technical, because I was struggling answering you as well.
I was just saying that you can tell that you created beautiful scenes in other softwares and imported them in TouchDesigner, because
exactly.
the complexity was really great, and the textures and everything looked amazing. And the first idea you showed that was not signed by the commissioner, like the one before the neurons, so the point cloud.
That was.
Was that also something you created, like the shape of the point cloud you created in another software and imported it to TouchDesigner?
No, you mean the blue one with the
with the particles.
With the particle, that's TouchDesigner.
So
with
you also created the shape of it in TouchDesigner because I really like that.
No, it's instancing sub operator. Basically, it's instancing with the particle, and that made in TouchDesigner as well. Yeah, I wanted to do in TouchDesigner as much as possible because at the end I would need it, so I better learn at the beginning whatever it is. So yeah.
That would be great anyway. Yeah.
Thank you.
So 15 minutes break. We're going to try something.
Oh, we've got some knowledgeable people. Anyway, well, thank you very much for having me again. It's awesome to be back in town, in person, and see a lot of familiar faces. Some I haven't seen in years. It's amazing, yeah, that this is possible again. So anyway, I'm really enjoying my time here in Berlin. It's great to be around, close to home. So yeah, I'm basically giving a little update on things that we've been working on. Something that has been very close to my heart, and I think last time I already showed a little bit of that stuff, is the O camera development. I'm not sure who knows this thing here. A fair amount of people, or few. So I'll give you a little introduction on that thing. Just at the beginning of the pandemic, I guess, there was this company called Luxonis that developed, they had a Kickstarter for a camera that initially looked, whoops, there. Let's see. Store, let's go there because I think you can still see the original one here. Right, this one here, the Oak D. So a camera with a stereo camera, left and right camera, and the color camera in the center. And on board of it is a little AI processor or machine learning chip. The benefit of this system was quite apparent. While perhaps in TouchDesigner we have a lot of these NVIDIA operators that do face tracking or skeleton tracking, or you use maybe a Kinect and the Kinect does your skeleton tracking, whatever. The problem there is that your GPU gets bogged down by the system quite a bit. And they went out to solve that problem by putting all the processing of these models onto the camera actually. So the camera can be, the camera takes the image, processes it after a model that you can, or the processing that you can design on the camera itself. And then it sends back the data that it's getting from, like if you do hand tracking or something like this, maybe you don't need the image from the camera, maybe you just need the skeleton from the hand. So then the camera would just send back this little data instead of data and image. And this means it's really scalable. You can have this with USB, then it's not so scalable because you need a lot of USB ports. But you can also have this as a power over Ethernet device, which means you can have them all over the place. You have long cable runs with this, and you're just getting back the data that you actually need from it without using too much of your precious GPU, or actually doing things that otherwise you can't do because, for example, this laptop is fairly old, and do I have this here? Face track. Oh no, is it gonna face track chop? Anyway, what I just want to, I don't even need to show you this. What I wanted to show you is that basically my computer is too old to run all of this stuff, but this is the solution though to this problem. So the other very, why did I like this when I saw it on Kickstarter was that the initial idea, what they thought to develop, was a camera to mount on their bikes so that they can get warned when cars are approaching too close. And as somebody who commutes to work on a bike, this struck a nerve with me because that's a constant issue for me. Cars that come too close to me. So the basis is something that feels very I feel very connected to, but the possibilities of it are great. The other thing is that it's a machined casing, and it has all the right attachment points so that you can mount it into your installations as you need. And the hardware and the software is open source, so it also comes as like basic building kits. So if you have an installation where you don't want to use a pre-built camera or something like this, you can also get these kits and build it right into your physical things that you might be building. Anyway, so this was a couple years ago, and then it took us a bit to get started on this, but we finally did. The model that I have here with me is this Oak D, is an older one. They now have the Oak D Lite, which is a much smaller model, but basically the same thing. You can see here the Oak D, the power over Ethernet, and now they also have this Oak D Pro, which also adds a laser projector and infrared receiver to help with dim lit environments, etc. So David Brown, who we got to work on this for us, he has developed now a set of operators, and I can just show you this. It's all based around this Oak device chop, which basically, it's just a chop with a sensor drop down and an active toggle and a callback DUT that's attached to it, because you're programming what the processing unit on the camera is doing. So this is completely flexible. That means you have to do quite a bit of Python programming to actually have it do what you want it to do. It can do, therefore it can do a lot of things like hand tracking, skeleton tracking, face tracking, people tracking, re-identification. So if somebody leaves and comes back, they can be re-identified. You can send it video. It doesn't have to use the video of the camera itself. You can also just use it as a co-processor, so sending it data. You can send it audio theoretically to do speech-to-text, things like that. So it's just a co-processor with a couple cameras attached. But as I said, that means you have to do a little bit of programming. And the basic pipeline that you're creating here, there's a basic example which essentially creates an RGB or connects to the RGB camera in the device and then outputs this as a stream. So having the Oak D or Oak device chop, you can also find a top which is called the Oak D or the Oak Select. And the Oak Select takes the Oak device chop, and now you got to enter the name of the stream that you want to fetch. So I have an RGB stream here defined, set stream name RGB, and I get the typical, oh, I hear it, and I get the camera, I get the camera from the, the color camera there. Similarly, there's also the, there's also an Oak chop or Oak Select chop, which when you create data channels, then you can fetch those as well, and I'll show you how that works in a second. Now bear with me, there might be freezes or there might be very uncommon crashes that happens. So you have access to the camera itself, to a lot of these camera parameters as well. So while you can turn on the camera and just get the color image with various resolutions, here we have a 1920 by 1080 resolution, you can also control features of the camera by, for example, changing the white balance of it or things like that. There is a very extensive set of camera controls that you can send up to the camera and control the camera's behavior like that. In this example, you essentially can create a camera control operator, and then every time you change the parameter, it sends up a different setting for the auto white balance mode. It's one of the things. You can also do full image processing on the camera, or not full, but I mean to the extent of OpenCV, what it allows you as image processing, you can do that on the camera itself. So if needed, you can rotate the image on the camera. Now this is funny, obviously, because it rotates. We can do this with a transform top, but that means that if you need to straighten images right on the camera, because you might check what the horizontal line is on or the horizon line on it, and you want to straighten it out, you can do this on the camera directly. This goes further to also include edge detection. And this would be an example of having actually the edge detection of 3 different cameras, different types of edge detection. Here, getting the left, right, and RGB camera and doing edge detection on it. So getting the 3 video streams out is separately is also possible. The scripts get a little bit longer with the more you do, obviously, and they're gonna get bigger and bigger as we look through these examples here. But luckily, Luxonis provides a ton of pre-made models that you can now implement in Touch, or soon, hopefully, implement in TouchDesigner. And obviously, we are building on a lot of examples that can be used right away by you. So in this example, this would be, for example, a person detector. I can see that this is a person. Good. I have a bottle here. Very nice. And again, for my poor little computer here that has a that's running on a 1070, it doesn't have any impact on the GPU. Those models are completely there. You basically can run these things now on whatever supports. No, you can run it on whatever, like a Surface tablet or whatever. Minimal computer requirements to run these models now because they're all on the camera itself.
Can I ask you a question about this?
Sure. I'm just checking if there's actually persons.
This thing is running an object detection technique, right?
Yeah.
Doesn't it give you access to the segmentation mask as well?
You can do that too, yeah. You can get segmentation out of there as well. I don't have that example, but I believe that is actually in, let's see where those come from. Let's have a look. MobileNet. Spatial detection. I thought I saw it somewhere here. But yes, it is possible, definitely, yeah. So yeah, with increasing complexity of what you're doing, these scripts, as I said, are getting a little bit longer and longer. The create pipeline is, the callback for create pipeline is executed once when you connect to the camera. So it's being sent up to the camera, and then the rest is being fetched. It's it's a pipe that just pushes data out at various frame rates. So the camera here currently, in these examples, it's running at 20 frames per second. While your TouchDesigner is, my TouchDesigner is trying to reach 60, but this is literally, again, I would like to point out that my computer is suffering from old age. It has nothing to do basically with what's going on the camera. So there is, when you run models on your GPU, perhaps you get better frame rates, obviously. But again, the drawback would be you're losing parts of your GPU on those things. This example here has is when not using the camera itself, but actually feeding in a video. And it's not too great, but you kind of get the idea that now I'm feeding video to it, I'm giving it data, and I'm analyzing it. So when doing, for example, skeleton detection or something like this on a pre-recorded video, this is it's great to develop projects now in a way that you have sample data and you don't need to jump in front of the camera, but you just give it the sample data to see what's happening in your installation.
A quick question.
Yeah.
Does this also work over network?
Yeah, because there's a PoE one. Mm-hmm. And the PoEs also get discovered the same way as the USB ones. They do come, usually you want to have it in a network with a DHCP server somehow, so that they get addresses assigned. If they don't get an address assigned, they get fixed IP, which you then can change, and then you need to put your computer in the same IP range. But they show up as sensors in the sensor tab. It's plug and play, essentially, in that way. And a couple other examples, because they're working really well, and these are getting a little bit more extensive. Now, while this looks like a very small script for the create pipeline, it actually depends on these three slightly more extensive ones. But yeah, there's various models that you can run on this. So this one is one of those media pipe models. These are all available from those are implementations taken from the Luxonis website. So taking the examples that are there and converting them into this TouchDesigner specific way. So this would be a hand tracking model. It didn't like this, it switched. But okay, I'm gonna, just to be safe. They are actually fairly responsive, like for what it's worth. It's not, like, it's pretty good. I found that, interestingly enough, overlapping, it's not too happy with, but it's pretty good.
Media pipe thing. It's running on the camera, it's good.
Yeah, exactly. Sure, yeah.
Are those scripts that you then push to the camera to do on-device processing?
Yeah, exactly, yeah.
And do you know what the protocol is for these models that shows? Like if I want to upload my own model, do you remember what kind of model it accepts?
I don't right now, but they do have a converter to go from, it's something Intel specific, but they do have the converter to convert from to, and
Yeah.
we'll just do this and restart. There's also the whole, is it called Intel Model Zoo? that's not it. I should have bookmarked this. There's also, but there's an, oops, that was the wrong build, sorry. On their website, there's a whole slew of models and examples that can be downloaded or ran with their test suite as well. Another nice feature here as well, a good implementation, is the face tracking. Which applies the face mesh. This is a little bit more, has a bit of a delay to it, but running fairly well too. And again, extensive looking, but do I have the link here? They're all built from examples from the Luxonis website. And the last one that I wanted to show is the motion recognition model, which is a little bit simpler. Apparently I'm always sad. This is ridiculous. Like neutral, how are you neutral? Anyway, yeah. So what our task now is, we have a little bit more work to do. We're trying to reduce the amount of scripting that you would have to do in general. This is, for example, when using video currently, when sending video up currently, it's a little bit of a script that you have to write to send the video to it, but this, we think we can internalize this to make it more straightforward, building those input pipes for you, and you just reference tops or chops to send up there. So this is something that we still have to do. And the other thing, we are trying to look at the differences, what our results are with the camera and what the results are when you run it with their test suite. So we're kind of comparing, we're trying to compare how well our implementation works in comparison to theirs. For example, here, when you get the point cloud out of it, it's not too, it doesn't look necessarily amazing, but the examples that they have on their website look quite a bit better. So we're trying to figure out where we might, where we have a way to go to get that improved. Yeah, this is pretty much the whole OAK-D development here that I meant to share with you, and that I'm fairly excited about, and hopefully see quite a bit of development from the community in that direction. Any other questions? Any questions towards this, or?
Not really a question, but maybe the examples they have on the website is really just a sales pitch and looks like that.
Sorry, what is
maybe
it?
the really good examples on the website are just under very ideal circumstances, and it just doesn't work like that.
Maybe, yeah. They do have all of the examples you can actually download from, like you can actually try them out as well. So, yeah, that is, you can cross-check their claims by running it.
So can you actually buy these, or is this some Kickstarter coming soon?
No, so the Kickstarter was 2 years ago, and since then they have been the team of Luxonis grew quite dramatically as well. They have been producing these cameras. You can buy them online, even in stock.
The governments are using these cameras too in China to track the people.
I I would assume. Yeah, I mean, sure. Yeah, there's since it's an open platform, you can use or abuse it at your liking. Definitely. Yeah.
Are there hardware bottlenecks like we saw with the Kinect during the pandemic, or do we assume these will be readily available?
They're actually fairly readily available. Like sometimes you wait a little bit for them. They have production runs, and obviously they're suffering the same issues as everybody else. So sometimes there's a supply chain issue with it too. But it seems that there's, because it is open source hardware, they don't seem to be affected by it as much as, No, very, I have a very good feeling about them, that they're going to be around for a while, and that we'll see more, like where they're pushing this, because just the idea how they're building it makes sense. It's made for, it's not necessarily for the entertainment or the business that a lot of us are in. It's more geared towards robotics and scientific research, and that actually gives me a good feeling, because there's a lot of considerations that they put into place, like how the hardware is designed and what it should, in what environments it should work, etc.
I think you mentioned that like on the cameras, these models are processed. Is it like, okay, you upgrade and then your models run like twice as fast or something? So is there like is there something like a scale factor? Or there was like this TOP unit somewhere. So is this like I don't know, like operations per something teraflops?
They have that, yeah. They do mention that here somewhere, what they're right.
Like whatever this means, but I was wondering, so like you have a very old model, so if you would buy this model, would your models run like, I don't know, 4 times as fast or something?
I don't know the scale factor there, I can tell you, yeah. But that's a good question though. 1.4, and what does this one have? Oh, it's the same actually. That's still the same processor here. I don't know how that scales, but I would assume that with more modern hardware, that will
looks like very, very, very promising hardware.
So have you compared these to Kinect or other NVIDIA local things and seen how it performs?
Yeah, so that comparison is a little bit hard, because you would have to take into consideration the hardware itself, like how tiny the hardware is, the price point, and the availability even of it, and usability. And then you can say that, okay, the Kinect is definitely has a much nicer point cloud, but doesn't afford you the option to have 50 of them in a network. So while there is drawbacks in certain scenarios, I think there's an advantage to this kind of a model, while in other scenarios maybe not. Yeah.
One more question. So I spent half a year optimizing latency for Kinect. So
how did
you
that go?
measure anything?
Question. I'm glad it's not just me.
Yeah, this is a very experimental build. No, we haven't done any direct comparison with the Z or Kinect or even RealSense. Haven't really compared them. Or for hand tracking with the Leap Motion. All that I based my observations on is literally just on testing and seeing, okay, can I see this in an interactive environment, or is the delay or the latency so
look really
huge?
nice, but
Yeah.
I was just wondering.
No, haven't done
Does
any.
it map depth as well?
Yeah, it has a depth. You can output the depth.
Is it as fuzzy as the
And it is fuzzy, yeah. Where is it? There's a depth example here. Oh, need to select the sensor. So currently, yeah. Ah. It's really not liking me right now. It's funny, the more I run it, the more it crashes, but I have a trust issue with my computer, so. Let me try again.
With this camera, you could replace it for Mann.
It should, yes, yeah. No, okay, sorry. Can't show you this, apparently. It's crashing on it. But yeah, so depth map is in there, and it is fuzzy.
So basically we have 10 more minutes. So
Markus, is there sort of an estimated public TV release, like Christmas or something? You hope it's
Christmas.
Yeah, it's really hard to say. Yeah, as per usual. This is it's hard, but we're fairly far along because the architecture is there. So there's a couple things that we will discover now on the way while using it, and we want to make sure that also Luxonis, like we want to have feedback from them as well, and then I think we'll have a better idea. But you know, it's in, as you see, it's in 20K, so maybe, I don't know.
One thing, since the particle GPU thing are in fairly because in the community, can you show us a little bit of the latest thing that happened on it?
The particle, let me see here. What did I do there? The leaves are back.
That's what was missing.
Okay, so now I don't know how well this runs here. Particle GPU. Yes. Okay, it runs, very nice, 60 frames per second, very good. Yeah, we did do a couple things. The camera was broken. This is fixed. The leaves are back because nobody liked my initial down swirly down thing. But I think this was because the camera was broken. But anyway, the leaves were apparently something that people really liked. And I realize also it's mean of us to change things, and then a bunch of tutorials are totally out of date. But sometimes we have to make those changes because it just doesn't. It's just the initial particles GPU had a certain set of features, but the new set of features are kind of they're breaking changes basically. So what came back as well is the let me just get here my video USB camera, and we'll get what is it called, optical flow. That was apparently missing as well. So now we have optical flow again, and if I just increase the force dramatically, let's do this. And yeah, you have optical flow input again. Really simple explanation why I didn't have this, because I never liked that optical flow is two-dimensional while these particles are three-dimensional. So I always was like, I don't like that. But I can see it being useful because, well, it has direct.
That optical flow in Z direction, the same text, right?
Yeah, it's just a. Yeah.
It's straight out from the camera?
Straight from the Oh no, not from the camera. That's a good idea actually. That should be in there, yeah. Nice. All right. The other thing was that you can also have particle source color. So when, let's say, when you're creating you're creating a whole thing from a noise, let's say here. How many minutes?
5.
5? Okay. That should be doable. -3 to 3 or something like this. So I have like something that creates those. This is just like my random, this is now my point, my particle creator here. And now if I render this with color type, sure, source input. Funny actually that this is already, wait, but I don't want leaves. I want squares, for example. Okay, and now I'll plug this into here, I believe. So now you can basically also plug in a colored, basically giving every particle that you create the color of the input. Then what else did we do? Oh yeah, there's a new hit behavior, which is fade out instead of die. So if it's optical flow still connected, interesting. Once it hits the border, it starts fading out. It starts dying basically. It's a little bit nicer. I thought maybe a nicer effect there. Very important. These limits. The limit plane is actually. There was a bug. It didn't scale with the parameters here. What else did we do?
Is this the same as the camera report for control?
Yeah, it's the camera component here, the camera report component, same one. Outputs are still the same. Might be interesting for a lot of you to see that your all of these textures are available for you. I'm only outputting position and what else am I outputting? Oh yeah, I'm only outputting position actually, but you can just grab any of these outputs if you need velocity or rotation or whatever from it. I reworked the whole rotation for the particles as well, so this is now working nicer or better. And I went over some of these parameters and resized the values. There was something of like they weren't when setting them, they're now more they make more sense basically. One thing that people also didn't see is when you have extra forces, there's a little, all of these inputs for forces and effectors have little example networks in the bottom here. And for extra forces, what you can do is, while there's only a single sample chop here, you can have a multi-sample force in there. So let me just copy this here. Of course. 0, sure. Let's take 3 and join them together. So now I have theoretically 3 extra forces for the particle GPU. Can reference that here, and now I should turn them on. Force amount, and you see one here. Turn this force amount on. this force amount on and move them a little bit. One, sure, like this. And so now you see that we have actually 3 forces in here. So you can add, I don't know how many, as many as you like. I haven't tried if there's a limit to it, but yeah, and I think this is all actually that I changed here. Oh wait, we can check. It's in the docs.derivative. It's in the release notes. Particle GPU, yeah, source color input, optical flow input, fade out hit behavior, camera is actually working, component starts with leaves, continuous rotation reworked, bounding box, and particle sizing reworked. Yeah, that's pretty much it.
I have a question. Currently, the extra forces are kind of in this dodecahedron space. Would it be possible to have like a sphere or like a square or like a box or like instead of this dodecahedron?
That's actually just the kind of just the.
So it's not the exact.
It's not really. It's modeled after the metabol algorithms that are in the metabol sub. So that's why I chose also a sphere for it. It is kind of spherical. They are spherical in just a simulation. I guess it must be
45.
Okay, so that's it. Great.
Got any other super secret shit Greg doesn't want us to know about?
Yeah, so since we're going to the bar,
We're still on stream, so.
wink, wink. That's it. Yeah. I'm being kicked off my chair. Okay.
It's me. Yeah, no, just like closing words. Thank you all for coming here again. As every month, also the reminder, we are always looking for not just participants, but also speakers. So if you have any topic that you would like to present, be it artistic, be it technical, be it another program, feel free to get in contact with us. And yeah, hope to see you next month, last Thursday of the month, especially for you in the stream, because I'm going to see, is it okay if I just show a little bit to the internet how many people are here? Okay, so
the X-ray with the robotic camera.
no, because we also have like this little camera here. I don't know if anyone has seen it. So say bye bye and see you next month.